Hi, so today I'm going to be explaining muscle contraction. So first of all, you have your muscle, and it's made up of a bunch of muscle fibers, and those muscle fibers are made up of little units called sarcomeres, and sarcomeres are made up of thick and thin filaments, which are, well, the more technical terms are actin and myosin. So first of all, we have our actin right here, yellow, and on the actin are tropomyosin, these like purple bands here, and the troponin, the styrofoam there. And so what happens during muscle contraction is, here's the other one. This is the myosin. And so they have the myosin heads, these green parts on here, and the popsicle stick is pretty much the whole myosin. So what happens during muscle contraction is they slide past each other, and that makes the muscle shorten. And so when a bunch of the filaments slide past each other, the whole muscle gets shorter, and that creates enough force to move the body. So from here we have just our two basic filaments. I have a key behind here. So first you have your actin, and then calcium, these calcium ions come along, and they attach to the troponin up here. And oh, where'd my other calcium go? Here it is. Okay, so once they attach to the troponin, oh, oops, wrong side. Once they attach to the troponin, the tropomyosin moves to expose binding sites, which are represented by the black dots here. So once the binding sites are exposed, here, I'm just gonna get rid of the calcium now. So once the binding sites are exposed and there's ATP, the myosin heads can bind to the binding sites. But first what has to happen is, well, all these kind of start, oh, oops, broke one. Okay, so all these start kind of down. They start down. And then what happens is the ATP here, it comes along. Yeah, so all the ATP is in there. And the ATP make it so that they can go and they can bind to the binding sites on the actin. And then once the ATP have, caused them to extend and bind, then the ATP go away, or they're hydrolyzed, I think, to ADP. So then you just have ADP. And this whole time, the myosin heads are still attached. So it takes another round of ATP, while they're attached, there's something that happens called the power stroke, and that's when all the myosin heads pull to one side, and that causes the actin to move, and that's how they slide past each other. Okay, and so then the myosin heads remain attached to the binding sites until more ATP comes along. So ADP leave, and then more ATP has to come along in order to allow the muscle to relax. So when your muscle contracts, it uses ATP for the myosin to bind to the actin, and after that it uses more ATP to go back to relax, to the relaxed state. So, so basically, that kind of explains what happens during rigor mortis. When it's like when you die, you stop breathing, and so you stop making ATP. So then if you have a muscle that's like stuck like this, and there's just the ADP in there, just the ADP, then your muscle is going to stay contracted like this. And it's only when the ATP comes back that the myosin heads detach from the actin and then can go back to normal. So that's why you get the stiffness after death of rigor mortis. And that doesn't last forever because eventually the cells start to decompose, and then they just kind of relax on their own through a process called autolysis. So that's that. And then there's a key in case you missed anything. Alright.